Good afternoon, everyone. I'm Greg Livingstone with Fluid Tech, and I am happy to have here Michael Parker and Preston Rubottom, and I am excited for this presentation because they're going to be asking us a question that every maintenance manager and every reliability engineer should be asking themselves: are your lubricants reliable? So, gentlemen, take it away from here. And one reminder for the audience here: feel free to ask questions in chat. We got some great experts on the line. Feel free to ask away, and we should save a few minutes here at the end to be able to address questions as well. All right, guys, on to you.
Yeah, so good morning. My name is Michael Parker, and I am the lubrication reliability consultant for lubrication engineers in North Mississippi and North Alabama. I've been in the lubricants industry for over 10 years now. I've dealt with some majors and some different distributors throughout the Southeast. So very excited to be here and be a part of this. And my colleague Preston Rubottom, he is the director of our lubrication and reliability solutions team. So I'll let him kind of introduce himself real quick.
Sure, thanks, Michael. So yeah, I'm Preston Rubottom, director of the lubrication reliability solutions team with LA Corporate. We work with manufacturers and refineries and different industries to stand up lubrication programs. So looking at treating lubricant like an asset to extend the reliability of the fluids.
Absolutely. So our presentation, are your lubricants reliable? Today we're going to touch on 4 topics: the importance of oil analysis, importance of ISO cleanliness codes, the importance of offline filtration, and importance of proper lubricant handling. So these 4 topics are what we feel as an organization are most important to achieving best practice to the reliability of your lubricants and keeping your lubricants and assets reliable and clean. So I will start this off. Importance of oil analysis. So a good oil analysis program, right? Why is this important? Well, a good oil analysis program is integral to any successful lubricant and reliability program. With consistent, accurate monitoring of the condition of your oil, whether it is an engine, gearbox, circulating system, or a mainline power generation turbine, an oil analysis program can help you improve your bottom line with less lubricant to purchase, fewer parts to keep in inventory, less used lubricant requiring disposable, and less labor and downtime. So when we think about lubricants and oil analysis, we think about these 2 things as being the backbone of your lubrication reliability program. So a severity scale, when we run an oil analysis, the first thing we look at on these charts that come to mind is a scale, right? You want to definitely see where you're at in a range. So the severity scale ranges from 0 to 4. And with these different ranges, you will see different languages that present themselves in the comment section. So typically 0, you're good. You're in normal limits. Your lubricants, they look great. Your assets operate like it needs to, and everything's smooth. You really don't have to worry about anything. When you see 1 come along on these reports, generally the language you'll see in the comments is minor. So contamination is at minor level. Around this time, you're kind of monitoring it, but you're really not planning to do a whole lot. I would recommend personally that you maybe pull another oil sample a little sooner just to see where you're at. Then you get to severity 2, and you start to see contamination levels that are moderate. When you see moderate contamination levels, that's when we're starting to plan, right? So we're looking at, hey, do we need to schedule to kidney loop our system? Do we need to be looking at possibilities of putting this piece of equipment down, worst case scenario? But this is where we really start to monitor this asset, as 2 and 3 are somewhat of abnormal levels in your oil analysis. So 3, that's significant. At 3, pretty much you need to get something going on this asset, this piece of equipment, and get this lubricant cleaned. And then 4, at this point, it's severe. You're shutting down, right? If you didn't plan time for your equipment, it's going to plan time for you. So at this point, you pretty much don't have anything else you can do except to shut down and change that out. So moving on. So you have 4 different categories on oil analysis. You'll have wear metals, contaminant metals, multi-source metals, and additive metals on these reports. As you can see, we have these highlighted. So these would be different categories that you would want to look at, and we'll dive into each one of these. So here's an example of a company that would need to look at having an oil analysis, right? This is a typical industrial manufacturing facility. They're having an issue with the worm gearbox. They've identified that they are currently using an ISO 150 extreme pressure lubricant in their gearbox, but constantly failing these gearboxes. They decide that they need to reach out to someone. So after they consult with a lubrication reliability expert, they decide to implement this oil analysis into their program to see what they can find as the cause of these failures. So wear metals, going back to this, when you're running an oil analysis, you don't want to think of it as just the oil that you're analyzing, right? This is a bigger picture than that. You're actually diving into the equipment. You're looking at different wear patterns and trying to determine what is the cause. So wear metals can identify components within the machine that are wearing. And it becomes really important here to understand the information that you are providing to the oil analysis company when you're submitting reports. And it's very important to submit all the information that is available to you. So all the OEM information, this will help to let the laboratory know what type of metal is in this unit. And if we see that flagged on these reports, we have a baseline to say where we at least think this is coming from. So in this picture, you see a worm gearbox. You see a ton of yellow metal here. And on this analysis, you would most likely see a very high copper number. So then we get into contaminant metals. These are typically environmental, and they can be explained more in depth by knowing the operating environment and the equipment. So again, it's very important to document everything when you're pulling these samples and submitting them to a lab. That way we kind of know what we're seeing in the report. This picture shows where a HPU unit has been, the top's been let off of it, and it has been exposed to particle contamination. Then you have multi-source metals and additive metals. These types of contaminants can turn up in test results for a number of reasons. The majority of the time, this is going to be the breakdown of your product. That's what you're going to see on these reports. So phosphorus, for example, if you have a report, going back to the gearbox example, if you have a report and you have a worm gearbox and you've identified that you were using an EP product, well, you're going to see that trend in this report. It's going to show a high phosphorus number, as that is what's used in an EP gear oil. So just kind of establishing, this is very beneficial for people that don't know what they're using. Maybe you had a new maintenance manager come in and he's trying to see the different lubricants and put that in to perspective of, these results, and the equipment fell in. This would be very powerful for them to tell, hey, this is the additive packs that we're seeing, and these are the lubricants we're using. So turbine oils, Preston, I was going to let you touch on this. You good with that?
Yeah, absolutely. Great job. So I kind of want to bring all that together, right? So we're looking at elemental, we're looking at contamination, we're looking at multi-source metals. What does it look like in the real application, and what else are we looking at? What else is what I want to bring to light here? So for that example, I use turbine oils. Turbine oils can go very, very deep, understanding the chemistry packages and the wear modes. But for a fundamental knowledge is kind of what I captured here. So for turbine oils, there's several factors to consider when looking at the overall health of the fluid. All of these factors are so important with turbine oils because there's a large volume of oil needed for specifically steam turbine oils. So for an organization to change out, say, 10 or 20,000 gallons, it's quite the investment. So we really want to understand the full spectrum of the lubricant that's in the machine. So we typically look at the following properties. So we look at the viscosity to make sure that the fluid film strength is there to protect the surfaces that the fluid is surrounding. We also look at demulsibility, so the ability to shed from water. Super important when you have a steam turbine with potential water ingression to have a good demulsibility rate. You want to shed that water from the oil and not emulsify. You want to be able to filter that out and remove it. Oxidation stability, the long-term life of that fluid is critical to know to give a proper planning process there. The resistance to foam. So there's mechanical aeration that goes on, looking at a fluid that's pressurized, going past very tight tolerances of valves and pumps and all the different surfaces in a machine. The fluid has to have ability to pop the foam, to shed that foam so it doesn't act as an insulating barrier. Air separation, very similar to the resistance of foam. Air separation, again, is the rate that the bubbles pop, so it doesn't add a insulating barrier to the fluid itself. And then, of course, long-term storage stability. So we look at, a lot of turbines have several thousand gallon storage tanks, so they can top off as needed to make up as that fluid evaporates. So making sure that the additives aren't falling out of suspension, making sure that there's other oxidation that doesn't occur with long-term storage.
Yeah, okay, thank you, Preston. I'm sorry.
Absolutely. So as we're looking at oil analysis, it's important to understand the ISO particle count. So we're going to dive into what ISO cleanliness is and what the particle count is. The ISO code is the standardized code of how many particles are in a sample when it's sent into laboratory. So we use this scale to quantify the particulate contamination per milliliter of fluid. Each of these numbers represent the correlating particle size of 4, 6, and 14 micron particle. So each code includes all particles of the specified size or larger. Okay. So what that code is brought by is this standard ISO code. So we look at the 4, 6, and 14 micron again. We bounce that off of this range. So as this fluid is being passed through the laser particle counter, we look at how many particles of this size, and we correlate it to the scale on the left. So we get a fluid sample, comes back and says, hey, your ISO count is, for example, the top bar is 24, 22, 19. We're again looking at the 4, 6, and 14. So just understanding that it correlates from the 4, 6, and 14 to this scale helps you understand what type of filtration you need if you are targeting a certain ISO code for the machine. So although you're armed with the knowledge of, hey, we have a 16, 14, 12 ISO particle count, well, what does that mean? How do I understand what fluid cleanliness needs to be for a certain asset? There's certain targets that are industry standards that are available for you to review and set up as your target for your program to make sure that that fluid is clean enough for the tolerances within that machine. So these are some examples here. Obviously, the higher the pressure, the tighter the tolerances of the machine, the cleaner the fluid needs to be. So with hydraulics, with servo valves, you want something around 15, 13, 11. That's extremely clean. You're going to have efficient filters in place, and you're going to have a very good scheduled process for filtration. Something with larger tolerances, such as a gearbox, you have a higher particle count. At the bottom of this chart, you can see where they're recommending a filter micron of 12 micron for gearboxes, to where if you need a count achieved of 15, 13, 10, you'd use a 5 micron. So the tighter the tolerance, the more strenuous the path, you're going to have a lot more cleaning capabilities with those. So this is really what it comes down to with filtration. we want to extend the life of the asset, right? We not only want to extend the life of the asset, but also the fluid. So these are target codes of fluids where we're looking at two different assets, a roller contact bearing or a hydraulic component. So for example, if you have a sample that comes back, say the hydraulic unit, it comes back at 25, 23, 20, like Michael just showed the picture of a hydraulic power unit that was heavily contaminated. So we can see the visual contamination, knowing that the human eye can see down to 80 micron. Those particulates are very large that we need to remove and keep from going in there. So we have extremely dirty hydraulic oil, 25, 23, 20 comes back. If we have effective filtration, it can stop the contamination and aggression, get down to, say, 16, 14, 11, that target code. We're going to extend the life of that componentry of the whole asset train five or more times. So it's critical for the life extension of that machine, also the overall runtime. So we talk about the particle ingression, but what does that have to do with the overall usefulness of that machine? Well, it's been said that 70% of loss of machine life is due to surface material. So again, a hydraulic unit, 1500, 2000 PSI, severe dirty oil acts as a mechanical sandblaster almost, eroding all the surfaces of the machine, either tight tolerance valves or rubber components that continually compound and get dirtier and dirtier, that ultimately leads to failure. So of that 70%, we look at how the wear mechanisms are formed. We have third body abrasion, which is the contamination from outside sources or internal degradation of surfaces. We also have 8% erosion and fatigue. So altogether, 82% of that mechanical wear is caused by particulate contamination. Either it's generated inside from having dirty fluid circulate or being taken in from outside sources. So filtration is critical, but also understanding where to start with your isoparticle count is the first step. Okay, so we know the particle counts. We're understanding how to scale and where we need to go. We have our target isoparticle counts, but how do we get there? So we're going to look at a few different offline filtration options here. Why do we need to filter? So brand new oil coming to the facility in drums, totes, pails, even tankers don't meet the cleanliness codes that I showed before. So for this reason, brand new oil should be filtered. Either it's going as it's going into the asset with a filter cart like you see here on the bottom, or with your storage system that has a dedicated filtration to it. So knowing that your fluid is clean before it goes to the asset is going to be very advantageous. Some people will also say, hey, we have inline filtration on the machine, so we have spin-on filters and other bag-type filters, duplex filters on the machine. Isn't that good enough? And typically the answer is no. So we're looking at different efficiencies of filters and mechanisms within the filter housings that could potentially lead to dirty fluid to be circulated around the system. And also understanding that offline filtration is it's called depth filtration in more cases than not, because it's a very tight path of travel to capture very small particulates. So looking at different types of contamination, water I mentioned earlier with the steam turbine is a very large potential contamination. So we want to understand that there's tools available to move water from lubricant oil or lube oil, excuse me. So through the process of vacuum distillation, all the water contamination is removed. So you have free water emulsified and dissolved. This system works by pulling a vacuum on the upper chamber. So you have lubricant that's emulsified with water. As this vacuum chamber comes down, we're boiling off the water. So we're able to evaporate the water out under a little bit of heat with vacuum. We also use the same principles with gases. So we can pull processed gases or different gases that get in lube oil out with this system. These systems are also equipped with particulate removal system. So very effective filtration. It can be very effective with this unit. Contaminations, large percentage per pass. Okay. Next slide.
Yeah, has it popped up yet?
Yep. Sorry,
Okay.
A little delay on my end, I guess. The next contamination we talked about, varnish potential in turbine oils. Very effective here for filtration. This is the process that uses either granular or absorbent or depth media to filter out the elements that remove dissolved and suspended oil degradation products. So all of those products actually lead to varnish, so we're trying to get ahead of that varnish plating out by using this offline filtration system. Varnish removal is often accomplished with oxidative stable media, and it's engineered to selectively remove varnish contents. So we're not going to pull additives out. We're not going to have to worry about changing the chemistry, solely the contaminants that lead to varnish here. So I mentioned there's several different types of filtration, and filtration is not a one size fits all. So just a couple of key reminders or key points when you're looking at filtration. But filtration systems must be configured properly for the optimal size. Optimal performance, considering the tank size, the oil viscosity, and oil temperature. We have to understand what flow rates are, and also how we can effectively filter that in a timely manner. And then by recirculating oil multiple times through one or more high efficiency filter elements, you can quickly, reliably lower the particle counts. And keep in mind that kidney filtration used on bulk tanks, oil totes, and drums is a very important, effective way to ensure that new oil is clean. But since the removal of particulate contamination, even with high efficiency filter elements, is not 100 or not 99% effective in a pass. So we have to recirculate and capture more of the particles as you circulate the system.
All right, thanks, Preston. That was very informative. And kind of playing off that, I'm gonna dive in a little bit to importance of proper lubricant handling. So that kind of goes hand in hand with what Preston was talking about when it comes to offline filtration. So here you'll see some lube storage units and a poor lubricant storage system, right? So why is this important? Well, a typical manufacturing facility, they're going to be unfortunately pretty dirty. Even the cleanest of facilities, they have the risk for airborne contamination. So when you look at these two pictures, and you look at the one on the left, you look at the one on the right, the differences you're seeing is that you have a proper way to not only store these lubricants, but that you also have a way to filter these lubricants as they're being stored. So back to what Preston was saying, the importance of doing this is that new oil as it comes into your facility is not clean, and it definitely needs to be filtered before entering your assets. You depend on these assets every day to keep your operation running at 100%. So you definitely want to make sure that these lubricants are clean. With these units, you have the ability to filter the product before you put it in the system, filter it as it's leaving the system, and also the opportunity to kidney loop it within the system. So what are we trying to do when we're talking about this offline filtration and proper storage handling? Well, we want to prevent contamination in the air, once again, from entering these lubricants and becoming a problem in your application. So you see here, this picture, it's a little aggressive, but it's definitely what we're looking to tackle, right? You have this bat here, which we're going to say it's about 40 microns. And you have, as little as 5 microns is all it takes to cause a precision rolling bearing to fail. So if this frog represents lubricant, you can see it's being highly contaminated by this particle. And before you put that into an asset, that can be devastating. So we're definitely wanting to get rid of these contaminants before they're able to hit the lubricants and be pumped through your equipment. So how do we go about that? Well, besides doing offline filtration, and proper storage, there's something else that plays a part in that, and that's these adapter kits, right? So you take these adapter kits, you put them on your hydraulic systems, your gearboxes, and they allow you to do several things. You're able to quick connect on these adapter kits with the filtration system to pump your lubricant into the system without having to open a reservoir cap like we saw on one of the slides that I had before, where all the debris was all over this hydraulic unit. Well, you can put an adapter kit on there where you don't have to unscrew those reservoir caps at all and easily be able to pump your lubricants in there, and also be able to kidney loop them while they're in the system. So along with this, adapter kits serve other benefits. You're able to customize them. So if you want to get to a state-of-the-art lube program and you want to identify your lubricants by color and shapes, you're able to do that as well. That way you kind of cut out the cross-contamination between lubricants. And then part of this is the desiccant breather. So you have these desiccant breathers that are able to eliminate rust-forming condensation. They prevent sludge deposits and water contamination, and they're ultimately going to reduce wear and tear on your equipment and provide longer oil and filter life if you can keep the moisture and those contaminants out of your lubricants. So another example here's a gearbox on the left before any type of adapter kits or sight glasses. And at this state, the gearbox is pretty vulnerable, right? It has a OEM breather cap on it, but as we know with what Preston was saying on ISO cleanliness and micron sizes, that's only going to do so much for you. So when you get moisture and airborne contaminants over time, they're going to end up entering this system. So a couple things here, right? If you have an adapter kit, you're able to cut that out and put your lubricants in there and avoid that contamination from the outside. But also you see on the bottom of this gearbox, you have a sight glass, and this is our drain adapter kit. So this is going to allow you to sample your lubricants with a sample port, drain your lubricants without making a mess. If you've been in this industry for any time, oil change is a big thing. So when you have to undo a plug and let oil drain in a bucket, you risk getting this all over the ground, right? So that's going to be safety issues, maybe a waste of product that didn't need to be wasted. So this is going to allow you to monitor your oil level, monitor the cleanliness of it, and also drain off moisture. And then here's a great example of these two units being used together. So we have the offline filtration cart, as Preston went over, along with the adapter kits. And when you pair these together, you're able to make sure that your lubricant is clean before it enters that asset, and you can do all you can with the filter cart to make sure you're achieving the best cleanliness possible in that asset. So a quick summary, by implementing these best practices that we've reviewed, it is our goal to have provided you with the information to apply at your organization, and not only define lubrication best practices, but also consider your lubricant itself as an asset to extend the life of your lubricant and rotational assets. So Preston, you have anything you'd like to chime in?
No, you did a great job there. Just the summary of driving reliability focused around your lubrication definitely pays off in multiple different ways.
Preston, Michael, thank you so much. Unfortunately, we don't have time for questions. So there have been some great questions in the chat, and I would encourage you to reach out directly to Michael and Preston. You can do that in the app itself and just communicate directly with them, and I'm sure they'll be happy to answer some of these questions. Awesome job, guys! Great job, and we'll see you guys at the next streaming talk here.
All right, thank you.
Appreciate it.
Thank you.